Let's try to visualize a plane. Imagine if you had a piece of paper and a pencil you had to pierce through the paper's center, like this. Now imagine if this paper's surface extended indefinitely. This endless paper would be your plane, and the direction of the pencil would be considered the normal vector of our plane. This normal vector is essentially a directional vector projecting from the surface on any given point on our plane. Because planes extend indefinitely, it divides space into two halves, each one known as a half space. Planes are useful for calculating which half an arbitrary point is located in. So for example, using the plane in our picture, I can tell right away that my dog is on the lower half of our plane, and my phone was on the upper half of our plane when I took this photo. Planes are also useful for finding the closest point on itself relative to another arbitrary point, like this. Walls, floors, and other flat surfaces are common in games, so a plane is sometimes useful for mathematical calculations with these objects. Also, there are cases where a real surface does not exist, but it is useful to imagine that one is there. For example, in sports, a goal line or out of bounds line is often assumed to be extended into the air, effectively defining a plane. Thankfully, Unity has a plane struct to easily make calculations using planes out of the box. So I have a scene here in Unity to build up on our pencil and paper metaphor. I'm going to create a script to attach to my pencil, which is going to create a plane using the paper's position and up direction as the normal vector. The paper's up direction is the yellow arrow that appears when I select it here. So I'm going to go ahead and create a script and call it Pencil Plane Creator. And from the top here, I'm going to go ahead and add a variable to reference the paper's transform component. And I'm also going to give our script a plane property, which we'll define using the paper's transform in just a moment. And the plane is a struct, and it's built into the Unity engine. There's no need to import any packages or other namespaces. And we don't need a start method, so I'll go ahead and delete that. Now in the update function, which gets called every frame, we're going to define and assign our plane property. So when I create a new plane struct, you can see from the IntelliSense here that the constructor is asking for two vector threes, an in-normal vector, which will be the directional vector of our plane, and an in point, and this is the position of our paper, which is the center of our paper and also where our pencil pierces through it. So we're going to pass in the paper's up direction as the normal of our plane, so that would just be paper transform dot up, and we're going to pass in the paper's position as the in point of our plane. And since this script is going to be attached to our pencil, I'm going to go ahead and move the script's transform so it's positioned onto the paper and also so it's oriented up with the paper. So transform.position equals paper transform.position, and then transform.up equals paper transform.up. Okay, so now we're basically defining our plane every frame. So it'll get updated as we change the rotation and position of our paper. And we're going to use the exposed plane property on this script to do calculations with it from other scripts. So I went ahead and added a makeshift player capsule here, and I want to use our plane to calculate the closest point along it to our player's position. We're going to visualize the point by positioning a sphere onto it. So I'm going to create a new script and call it closest point on plane. Now in our script, I'm going to add a reference variable to our pencil plane creator. And we're also going to store a reference to the player transform so we can get its position to calculate the closest point along the plane. So now in our update function, we're going to assign the script game object position, so transform.position, and then use our plane creator reference dot plane property. And then here we can already see from IntelliSense a few helpful functions appearing. We're interested in the closest point on plane method, which takes a vector 3 position. As I'm sure you can imagine, it returns the closest point to the position you pass in along the plane. So I'm just going to pass in the player position. So now let's go see this script in action. Back in Unity, I'm going to create a sphere game object and then add our closest point on plane script onto it. Make sure to assign our references to the script. So we'll assign the plane creator from our scene, and then we'll assign the player capsule to the transform reference. Once we hit play, we can see the script is working as you'd expect. The sphere is being repositioned onto the closest point to the player on the plane. And you can see the sphere is being precisely bisected by the plane as we move or rotate the plane or player capsule. Okay, so now let's look at another problem we can solve using planes. Remember that a plane splits space into two halves. And as you can see, the surface where the pencil is coming out of our plane is the positive half, or upper half of our plane. And where the pencil is going into our plane is the negative half, or lower half of our plane. I'm going to create and attach a script to our player capsule that will let us know which half the player resides in on our plane. The script will change the player's color to green if it's on the positive side, and red if it's on the negative side. I'm going to create a script and call it identify side on plane. And on the top, I'm going to add a reference variable to our plane creator in our scene. And I'm going to add a reference variable to the material on the player renderer. I'm just going to call this variable render mat for render material. And in our start method, I'm going to assign our render material, so render mat equals get component mesh render dot material. And then in our update function, I'm going to check which half of the plane our player is on. So if plane creator dot plane property dot get side, and you can see here the get side method takes a vector 3 position. And what this function returns is a Boolean value, which is true if it's on the positive half, and then false if it's on the negative half. So continuing our if function, if the player is on the positive side, I'm going to change the player capsule to green. And if the player is on the negative side, I'm going to change our player capsule to red. Now back in Unity, I'm going to attach our identify side on plane script to our player capsule, and then assign our plane creator reference to the script. And then when I hit play, you can see the player is green when it's on the positive side on our plane, and red when it's on the negative side. And as you might expect, this will always work whether you move or rotate the plane or the player. Another problem that's easy to solve is calculating if and where a ray intersects with the plane. Let's say we're using this gun to raycast projectiles out of it, but we want to know if the ray intersects with our plane here, and if it does, where does the ray intersect with it? Let's see what that looks like in code. So I'm going to create a script to attach to our gun and call this script ray plane intersection. And on the top, I'm going to add a reference variable to our plane creator. And in our update function, I'm going to create a new ray to check against our plane. Our ray's origin is going to be the position of our gun, and the gun's barrel is pointing forward. So I'm going to pass this forward direction to the ray's direction. And now we can test if this ray intersects with our plane. So if plane creator dot plane property, and then use the raycast method on the plane. So this method takes a ray to test against the plane. If the ray intersects with the plane, then the method will return true and false if it doesn't. And the method also outputs a float number, which is the distance along the ray where it intersects with the plane. Of course, that is if there is an intersection. So continuing our if function, I'm going to draw the ray of our gun if it intersects with our plane. So debug.drawRay, and pass in the ray's origin for our drawn ray, and then pass in our direction of our ray scaled to the distance where it intersects with our plane. And I'm going to color this ray green. So back in Unity, I'm going to select our gun and add our ray plane intersection script to it. Assign the plane creator reference to the script. And now when we hit play, we can see the ray projecting from our gun and landing precisely along our plane. And of course, when I rotate the plane or gun away from each other, our ray no longer gets drawn because an intersection no longer exists. There's more to the plane struct than what I've shown in this tutorial, so I encourage you to explore the plane documentation, which I've linked below in the description. Thanks for watching. I hope you found this tutorial useful. If you want to show your support, please check out my live stream where I'm showcasing an augmented reality video game played between my two pet fish. They play soccer and shoot lasers at each other. You can place bets on them if you want. It's frustrating but fun to watch. I put a link in the description below if you want to check it out. Thanks again.